Hello, my dear students. Today we are going to study classification of element part 2. Last time what we saw was the history of periodic table, starting from Taubenier trade, Newland octave, Mendeleev periodic table, and then we finally have our modern periodic table that we all will study today. What is the basis of classification of element of modern periodic table? So the answer is it is increasing atomic number. Now, why do we need a classification? Why we have a classification of element? So that it becomes convenient and easy to understand their properties, physical property or chemical property. For example, if I ask you what is the day today, so it's Wednesday, right? Now after how many days Wednesday again comes? After 7 days, right? What is the month going on? May. Now how many months after May will again come? It is after 12 months. So this concept is fit in our mind that after 7 days the same day repeats, and after 12 months the same months repeat. Here in periodic table, if you see, for example, carbon, okay, now carbon, below that silicon is there. So if I tell you the carbon periodicity or the similarity, again it will come, but again carbon won't come. Some similar element will take that place, which shows the same chemical and physical property as of carbon. This is known as periodicity. So in similar manner we will see other properties also in this chapter, like how the valency, atomic size, the electropositive character, the electronegative character, metals, non-metal characters have similarity, have the trend that we are going to study today. Student, don't worry. This is not all periodic table that you are seeing you have to study. So the good news is, from atomic number 1, that is hydrogen, till calcium you need to study for your 10th standard, because most of the question will be asked from these atomic number from 1 to 20 elements. Okay, I'll tell you what is group number 1 called. Now group number 1 has a special name known as alkali. Second group has name alkaline earth metal. 17 is known as halogen and 18 is known as inert gases or noble gases. Now I have not given you any names between 3 to 16 because they don't have any special name. Rather, the D block, that is from group number 3 to 12. Now let me explain you how the properties varies in periods and groups of the periodic table. Now there are 18 groups in the modern periodic table and 7 periods. 18 group, hydrogen 1, hydrogen lithium, that one is first, beryllium is second, and so on, 3, 4, 5, halogen is 17 and inert gases is 18. So from top to bottom, if you go, those are groups, and if you go horizontally, that is hydrogen, helium, that is period number 1, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, that is period number 2, sodium, magnesium, that is NaMg, that is written, that is period number 3, and so on. So 18 groups and 7 period. The F block we will not study here. You will study in higher classes. So we will not talk about this. Now students, let us see electronic configuration. Now you all know the number of electrons that is present in an element is same as the number of protons present in the nucleus. So basically, for writing the electronic configuration, we have to focus on the number of electron, or we can say proton, or in the other way we can also say it is the atomic number. Atomic number is nothing, it is the total number of electrons or proton present in any element. Now let us first see some rules that we have to understand, and then we will go to how to write the electronic configuration. In 9th standard already you have studied. Now there is the atom. In the atom, nucleus is present. Proton and neutron are present inside the nucleus, and electrons revolve around the nucleus in a specific orbit. How? It is like planet revolving around the sun. Similar, the electron revolve around the nucleus. Now we have to see there are 4 shells. The orbit, they are also called as shells, and these cells are named as the first one, or the first orbit which is the closest to the nucleus is K shell, second L, third M, and fourth N. Till here only you have to study K, L, M, N. So the rule is the number of electrons that will be filled in each shell will be different. For example, the capacity to hold the electron for K shell is 2 electron. For L shell it is 8 electrons. For M shell it is 18 electron, and so on. Now this we can see with one example, and it is also shown by one formula, which is 2n square, where n is number of the shell. Now if you see here, you apply any shell, for example 3. So you will have 2 into 3 square. So 2 into 3 ka square is 9. So 2 into 9 is 18. That means the third shell will have the holding capacity of electron that will be equal to 18. You can calculate for any shell now. Now fourth one, if you see, 2 into 4 square. So 2 into 16. So 32. So the fourth shell can hold how many electrons? 32 electrons. So these are the rules that you have to follow. Also, if the first orbit is filled, that means the closest one, if it is filled, then only the electron will be filled in the other orbits or other shells. What I am trying to say, like K shell has 2 electrons to have. Now if 3 electrons is present, so 2 electrons will be first filled in K, and then the third one will go into L. So this is the rule. Now for M and N, the rule is that M can hold 18 and N can hold 32. But for now, just remember that M will hold 8. First 8 electrons will be filled, and then the 9th electron will go into the N shell, and there also 8 electrons will be filled. So in spite of the holding capacity of electron is 18 for M, but still it will have 8. These rules and these understanding, it will come when you go in higher classes. Okay, so now let's begin to write the electronic configuration of the element. So first I will show you the first period, second period until third period I will show you. Okay, the first period is hydrogen and its atomic number is 1. So, one electron is present that will be filled in the K shell, that is first shell. Okay. Now come to the second period. In that I have taken fluorine. Now you can see it is having 9 electrons. So 2 electron in K shell and remaining 7 electron in L shell. In third period I took sodium. So you can count sodium, the atomic number is 11 and the electronic configuration is 2, that means K shell 2, 8 L because it contains 8 electrons, and the remaining one will go in M shell. Okay students, now also I have given you here fourth one, that is potassium, which has atomic number 19. So 19 electrons are present. First shell 2 electron, then after completing it will go into L shell 8 electron, then it will go in third 8 electron, but this ninth one won't remain in third, it will go in fourth. So N shell, right? The last electron will go in N shell. So there are altogether 4 shell KLMN in which the electrons will be filled for potassium. Students, if you look here in group, the first group that I am telling, that hydrogen, lithium, sodium and potassium. What is the change that you are going to see here? In hydrogen, there is just one shell and one electron is present. In lithium, there are 2 shells, so 2 electrons in first shell and 1 electron in second shell. Third, 3 shells has come, 4 shells has come, and it will go like that. So if you go from top to bottom, the number of shell increases. If you go in second group also, you will see for beryllium there are 2 shells, magnesium 3 shells, calcium 4 shells, and if you see the number of electron in the last shell is increasing if you go from left to right, that means in the period. For first, that is hydrogen, you will see in K shell 1 electron, and for helium, okay, if you see, the K shell is filled with 2 electrons. Now come to the second period, lithium. So lithium, how many, which period it is? Second period. So how many shell? 2 shells. Okay, so lithium 2 1, beryllium also. So every element in this period will have just 2 shells, and in those 2 shells the last orbit or the last shell will only have the addition of the electron. Okay, if you see lithium 1, beryllium last is 2, boron is 3, carbon is 4, oxygen is 6, and so on. So while going from top to bottom in the group, the number of shell increases. So first element will have only one shell, second element will have 2, third 3, and it will go further increasing in groups, meaning top to bottom. But in periods, the number of shell remains the same. That means if you see the third period, it has 3 shells. Okay, and it remains from left to right, the number of shell remains, only the electrons are added in the outermost shell. Okay, so you can understand and keep this in your mind that from going top to bottom the number of shell increases, and from going left to right the number of shell doesn't increase, only the number of electrons is increasing in the outermost shell. Now the number of electron present in the outermost shell is known as valence electron. I hope everybody knows that. For example, for sodium, the valence electron, if I ask you what is the valence electron of sodium, it is 1, because the outermost shell, which is M, has 1 electron, so its valence electron becomes 1. For magnesium it is 2, for lithium it is 1, for nitrogen it is 5, and so on. Let's see the valency first in group and then we will see in period. So consider the group 1. Now in group 1, hydrogen, lithium, sodium and potassium is there. Okay. Now students, the outermost orbit electron is present and at the center nucleus is present. Okay. So there is a nuclear force of attraction because nucleus is positively charged because of presence of proton, and electron which is negatively charged, there is force of attraction between the nucleus and the electrons. Now if you see, if electron is releasing or it is donating to any other element, the nuclear force with which the electron is attracted towards it has to be less. Then only it can go out of its own shell to donate that electron. So the size, if it is small, the tendency to give electron will decrease because of more force of attraction between the electron and the nucleus. Similarly, if the size increases, the force also decreases and hence the tendency to give the electron increases, because if you compare all the element has one electron in first group, hydrogen also one, lithium, sodium, potassium. So if I ask you which of the element can donate the electron easily, so what is the answer? It should be potassium, because the size is more, the force of attraction between that valence electron will be less by the nucleus and hence it can donate the electron easily. Now what is the valency? The valency from top to bottom remains the same because the valence electron in all these elements is 1. So the valency, that means it has the tendency to donate the electron. So the valency of first group is 1, it remains same. Second group, the valency will be 2. Third group, the valency will be 3. Okay, so the valency remains same from top to bottom. Now let us see what is the trend of valency in the period from left to right. So if you consider the second period, lithium, beryllium, boron, carbon, nitrogen, that one. If you see, lithium is starting with 2 shells, 2 and 1, and similarly all other elements also have 2 cells, but the last shell has increasing electron. Lithium has 1, beryllium has 2, boron has 3, carbon has 4. So lithium, just 1 electron is present, so it can donate easily. Beryllium 2, it can also. Boron 3, it can also donate electron easily. Carbon, it is not easy to donate or receive, so it will share the electron. For nitrogen, to give the electron, 5 electron is so much energy is required. So it will receive the 3 electron to complete its outermost octet, that is 8. Similarly for oxygen, it is 6. It won't be able to donate 6 electron, rather it will receive 2 electron. Fluorine, it will receive 1 electron, and neon, it is already having fully satisfied outermost shell, that is 8. So if you see so valency in period first increases and then decreases. That means lithium 1, valency will be 1, beryllium valency will be 2, boron valency will be 3, and then carbon won't be donating the electron, it will share. Nitrogen 3 because it will accept the electron. Oxygen 2, fluorine 1. So from left to right, first the valency increases and then it decreases. So I hope you understand the concept why it is increasing and decreasing. Now you have to see the atomic radius in groups and in period. So in group, the number of shell is increasing, hence the radius, atomic radius will also increase. What about in period? In period, the number of electron in the last shell is increasing, hence the more electron, more negative charge and more attraction towards the nucleus. So if there is more attraction towards the nucleus, the atomic radius will be less. So if you go from top to bottom the atomic size increases, but if you go in the period from left to right, the atomic size decreases. Now come to the electropositive and electronegative tendency. What is the trend? In the group, the electropositive trend will increase. Why? Because the size is increasing. Electropositive meaning any element that can donate the electron easily. So as the size is increasing in the group, the tendency to release the electron will also increase. Hence, from top to bottom, the electropositive character increases. What about the group? What about in period? Now in period, the atomic radius is is decreasing. The electron which is present in the outermost shell, you have to consider that. So lithium is 1, beryllium is 2, boron is 3. So 1 electron from lithium, 2 electron from beryllium, 3 electron from boron can release. From nitrogen it will take, oxygen it will take. So electropositive character will decrease, okay, because donating of electron is decreasing, because taking of electron is increasing. So electropositive character decreases and electronegative character increases, okay, we can say in that sense. So from top to bottom, electropositive character increases, and from left to right in period, the electropositive character decreases. So all these three characters or the properties you have to study. First was the valency. So in top to bottom, the valency remains same because the outermost electron is same in all the elements from top to bottom. In period, the valency depending on valence electron, so first it will increase and then it will decrease. That means first it will donate, okay, till 3 electrons, and then sharing of electron, and then it will start receiving it, okay. That is nothing to do with the valency. I'm just telling you to keep it in this in mind. So first it will increase to 3 and then it will start to decrease, okay. So valency in group, from top to bottom it's same, and from left to right it increases and then decreases. What about the atomic size? The atomic size, the number of shell increasing in top to bottom in groups, so atomic size increases. What happens in period? From left to right, the number of electron is added in the same shell. That leads to increase in the nuclear charge, force of attraction between the nucleus and the electron, and hence the atomic size decreases, okay. And because of that, the electropositive character also has the trend. From top to bottom in group, the electropositivity increases because of the greater size, atomic size. The tendency to release the electron becomes faster, and hence the electropositivity increases. In left to right in period, the electropositive character decreases because the tendency to donate electron decreases. Hence the left side of the element are metal, whereas the right side of the elements are non-metal. Those are electronegative elements. So this is the trend, students, you can see here. You just pause and you can understand and comment. Now the last topic is gradation in halogen family. Halogen family meaning which group? 17 group, that chlorine, fluorine, bromine. Now what is the meaning of gradation? It is a gradual change of some characters, okay. So it is found that from top to bottom, the state in which these halogen families are present, so first few elements are present in gaseous form, and then the bromine is present in liquid, and Iodine is present in solid form. So this is a gradation of physical state in halogen family. Just in halogen family you have to remember. So only one group you have to study. So remember this, student. Fluorine, chlorine is in gaseous form, bromine is in liquid, and iodine is in solid. Why I'm not telling as statin? Because we don't have to study for now. So this complete your classification of elements, student. I hope everything is fine and you have understood the concept behind the classifying the elements. Thank you so much, students.